So I'm actually going to use the examples in 4.2 to explain 4.3, which is factoring a quadratic in the form of x squared plus bx plus c. So essentially what I'm saying, or maybe what I'm not saying, is the leading coefficient in front of the x squared in all of these examples is 1. The next lesson, I believe, let me just look at, is going to be when there's a leading coefficient and that coefficient is not 1. And that's just an extra step to do. So let's just start with this example. So here's my example 1. And I'm going to start with x squared plus 2x plus 1. So when I take a look at this example, I look at the coefficients first and I say, okay, can I pull a common factor out? 1, 2, 1. I can't, yes, Tony. I can't pull a common factor out and I can't pull a variable of x out. So I'd look at this and I'd say, okay, well, I'm done. I can't do anything. And you're right, common factoring. I can't pull a coefficient out in front and I can't pull a variable out in front. So you would think that you were done. Now, what we're going to talk about today is how you actually factor quadratics. What you do to factor this is you look for things that multiply to the outside and add to the inside. And by that I mean, remember there's my invisible 1 out in front. So I'm looking for numbers that multiply to positive 1 times positive 1 is positive 1 and add to positive 2. Well, that's pretty easy. The only things that multiply to 1 are positive 1 and positive 1. Could be negative 1 and negative 1. But of these two combinations, because positive 1 times positive 1 equals 1, negative 1 times negative 1 equals positive 2, which of these two add to positive 2? That is the only combination that multiplies to the outside and adds to the inside. Okay, I need to move the cat. Sorry, just wants to go outside and eat a bird. Okay, so I'm looking for two numbers which multiply to 1 and add to 2. The only two numbers that do that are positive 1 and positive 1. So for this first example, what you can do is you can just take the numbers that multiply to the outside and add to the inside and stick them into that format. And you're done. You've actually factored it. Technically, because this is the same thing twice, x plus 1 times x plus 1 equals x plus 1 squared. You've actually factored your quadratic. How do you check if it's right? Well, what you would do to check if it's right is you would take x plus 1, and you would use FOIL. Remember? First, outside, inside, last. So x times x is x squared. X times 1 is plus 1x. 1 times x is plus 1x. And 1 times 1 is 1. If you take a look at that, you end up with x squared plus 2x plus 1, which is what we started with. Okay, so really important for your multiplication skills here to look for things that multiply to the outside and add to the inside. I'm just going to go through a whack of examples with you, and that way you don't actually have to do section 4.2. I will do it for you. Okay, let's take a look at example 2. These questions, incidentally, are coming from page 205, if you want to look at it in the textbook. This is II. So I have x squared plus 5x plus 6. So I'm now looking for two numbers which multiply to positive 6, 1 times positive 6, and add to positive 5. So some of the homework for the getting ready was looking at multiples of numbers. This is why they had you do it. What numbers multiply to 6? Well, you can have 1 and 6, 2 and 3, 3 and 2, and 6 and 1. And you'll see when I post my solutions for my homework, you'll always see this like little chart of numbers at the side. And it seems like a little bit too much work, but later on it'll make sense why I do it. Once I get halfway, and by halfway I mean 2 times 3, and once I get to 3, I'm just actually using the same multiples in reverse. It becomes really quick. So you really only ever have to get halfway with your numbers, and it will make more sense when I do more examples. So which of these multiplies to positive 6? If these were all positives, right? I would say, well, all of these multiply to 6. Which are the ones that add to positive 5? Not this one and not that one, because that adds to 7. So this works. Positive 2 times positive 3 equals positive 6, and positive 2 plus positive 3 equals 5. That means I can straight away just go to this and put in plus 2 and plus 3, stick in my equal sign, and I've common factored. Okay, let's look at the next example. I have x squared plus 6x plus 8. So I'm looking for two numbers that multiply to positive 8 and add to positive 6. So I have 1 and 8, 2 and 4, 4 and 2, and 8 and 1. And that's what I mean. Once I get to 2, there's 3 doesn't work, 4 works, but then I'm just kind of doing these two backwards. So you really only have to get halfway, and then it just becomes the same thing. So I'm looking for numbers that multiply to 8. All of these multiply to 8. Which of them add to 6? Well, that doesn't. That adds to 9. So this works. And whether you pick this one or that one, it doesn't matter. Whether I have x plus 2 times x plus 4, or I could also have x plus 4 times x plus 2, doesn't make any difference. 3 times 2 is the same as 2 times 3. So either of those are correct answers. I'm just looking for something that multiplies to the outside, remembering the coefficient here is 1. 1 times 8 equals 8 and adds to 6. Okay, let's see if I can save some paper trees here and write in the back. I hope that's okay. Let's take a look at something with a negative number. So let's take a look at question number 4. I have x squared minus 2x plus 1. So I'm looking for two numbers which multiply to positive 1. Remember, there's an invisible 1 times 1 is 1 and adds to negative 2. This example would be 1 and 1. And I can either put positive, positive, but I know that that's not going to work because that's going to add up to positive 2, which is not right. So if I take negative 1 and negative 1, negative 1 times negative 1 equals positive 1, and negative 1 plus negative 1 equals negative 2. So those are the right combination of numbers to factor this equation. So then this becomes minus 1, minus 1. Let's just do a super quick check to make sure that that actually works. I'm going to use FOIL. First, outside, inside, last. So I get x squared minus 1x plus 1, because negative 1 times negative 1 equals positive 1. And when I collect like terms, I get this, which is exactly what I started with. So I know that my answer is right. Okay, on a test, you're not going to show me this because I'm actually asking you to factor or asking you to put the brackets in. So I don't want to see this, but if you want to do that on a scrap piece of paper, or if you want to do that in your head, that's fine, but I know that I've done it correctly. B1. So I have x squared minus 2x minus 3. So I'm looking for two numbers that multiply to negative 3 and add to negative 2. So 1, 3, 3, 1, right? And you'll be like, well, why do you do this? As soon as my numbers multiply to a negative, I know that one of the numbers in my pair has to be negative. That's why I always write all of them down. And then I just put all of the negatives down my left column, because if all of these are negative and all of these are positive, then the product of those two is going to be negative. So for example, if I had, what did I have in another question? I had, I don't know, let's look at the factors. I'm doing a timeout here. Let's look at the factors of 12. You would have 1 and 12, 2 and 6, 3 and 4, and now I'm halfway, so I'm just going to repeat them backwards. 4 and 3, 6 and 2, 12 and 1. If my question had something like blah, 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 minus 12, I would just put negatives all the way down the left-hand column, because I know that now this is negative, 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 and then I can look for the right pair. Okay, so going back to my example, I'd say, okay, multiplies to 3. So I either have 1 times 3 or 3 times 1. I'm going to stick, because it multiplies to -3, I'm going to stick my negatives out in front. And now I need to pick which of these two actually gives me a sum of -2, which adds to -2. And I can see that in this case, the answer matters. This pair, -3 times +1 equals -3. -3 plus 1 equals -2. That is the right set of numbers to make this work, to make the factoring work. This doesn't work. It multiplies to -3, but it adds to +2, so that's not the right set. I need to look at this set. Once I found my right set, I do exactly the same thing. I had -3 and +1. Okay, let's do a couple more of those. And okay, I am looking for two numbers which multiply to -8 and add to -2, right? So I have 1 and 8, 2 and 4. I'm halfway, 4 and 2, 8 and 1. Because it's multiplying to something negative, I make all of my left column negative. And now I just look for the combination that adds up to -2. It's gonna be this one, right? I have -4 plus +2 equals -2. This is the right combinations. These don't work. So that becomes x minus 4, x plus 2. So not so bad. Okay, I think maybe I'll do 2 more examples and then I'm going to stop. This is B5. I have x squared minus 3x minus 10. So I'm looking for two numbers that multiply to the outside, so they're multiplying to -10, and they're adding to -3. So my choices are 1 and 10, 2 and 5, 5 and 2. These markers are brand new and they're already dying. 10 and 1. Okay, so all those multiply to 10. Because it's negative, I'm just going to make my left-hand side of my column negative. So now each of these pairs multiply to -10. Which of these adds to -3? That's the only answer. So this becomes x minus 5, x plus 2. And you're done. So it doesn't look that hard. It isn't that hard. You just have to practice doing it. Let's do one last one and then I'm done. X squared plus 4x minus 5. So I'm looking for two numbers that multiply to -5 and add to +4. So I have 1 and 5, 5 and 1. Because it's multiplying to negative, I'm going to make that negative. Which of those add to +4? This one adds to +4. This one adds to -4. This one adds to +4. That one works. And I'm left with x minus 1, x plus 5, sticking my equal sign for communication marks. That, my friends, is 4.2 and 4.3. We spent 2 weeks last year on this. This is such an important skill that you will use in physics. You'll use in grade 11 and grade 12 math. If you're going to college or uni, you'll use it. Factoring trinomials is so, so, so important. So if there's any place that we had to start off with, I think this one's okay to do online. I gave you guys all Algebra with Pizzazz worksheets. You are going to do them until you are bored stiff, but I can't emphasize how important it is to do all of the homework and practice, 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 because the more you do of these, the easier they get. I make it look really easy because I know what I'm doing. I've done it a lot. You have to also practice it so that you can get good at it as well. Okay, so that's it for now. Hope you guys are all well. You know where you are. Hope you're all well and safe. Social distance. Bye. The cat woke up, but he does seem a little bit bored. Hey, Tony. Yeah, super bored.